This video is on applications of Pythagoras theorem, and it will help you with task 3 of your assignment. An example question is, a bird flies in a straight line from location A to a mountain range. Here is location A, and here is a mountain range. The peak of the mountain is 500 metres above the ground level. 500 metres above the ground. Here you see the ground. The peak of the mountain at the very top is 500 metres. So I'll label that 500 metres. And it was also, the peak is also 2 kilometres from the bird's initial location. So the peak is 2 kilometres from the bird's location. That is referring to the top part of the mountain all the way down to the bird's location. Now that is 2 kilometres. We always want to make sure that we're using the same units of measurement when solving problems. So we'll convert 2 kilometres into metres, times by 1,000. 2 times 1,000 is 2,000 metres. Okay, and lastly, the bird flies exactly 100 metres over the mountain peak. So we're going to add 100 metres to over the mountain and label that 100 metres. The red diagram has been redrawn in blue in a metre way. Now the question being asked is, what distance is travelled over the ground from point A to the mountain peak? Now if you imagine travelling over the ground, the bird may fly from point A to the mountain peak, or above the mountain peak. Just wanting to know, if it went to this location, how far over the ground is it travelling? So our unknown is in this position here, so I'll label it X. Now, get rid of that so we have some more room. Now we know this is a right-angled triangle, and we've been given 2 sides, which means we can use Pythagoras theorem to calculate the unknown side. Knowing that c squared equals a squared plus b squared, remember c is always the hypotenuse, the longest side, so we're going to need to rearrange our formula to allow to find what a equals. So by taking b from both sides, we're allowed to have a squared by itself, which equals c squared take b squared. Now I'm going to substitute in the values for c and b in order to find a squared. C, the hypotenuse, is 2,000 metres. 2,000 squared take b, which is 500, 500 squared. Pop that into your calculator. We found that a squared equals 3,750,000. Now we don't want a squared, we want to find what a equals, so we'll find the square root of 3,750,000, which, putting it into your calculator, that equals 1,936.491673 metres. Now you'll notice I've left a lot of spaces after the decimal point. That's because I want the most accuracy as possible. Question 2. Calculate the actual distance covered by the bird to 100 metres over the mountain peak. So if the bird leaves this location and flies over the mountain 100 metres, okay, that should be a straight line, we now want to know what this value would be here. So I'm going to call this unknown, this yellow unknown, I'll call it y. Now, we are given this side here, which we can call a, and we've just worked out this side here, which we can call b. So again, using Pythagoras, we can work out this hypotenuse, which we've labelled here as y. We know the mountain peak is 500 metres, and the bird flies 100 metres over that, so a will be equal to 500 plus 100. So a equals 600 metres. Let's substitute that into Pythagoras theorem. 600 metres squared. B is this number we've worked out here, and I've left all of those decimal places for accuracy, so I'm going to put them all in. 1,936.491673, and we'll square that. Let's put that in our calculator. Finding the square root in order to find c is 2,027.31 metres. So your answer is, the actual distance the bird flies is 2,027.31 metres. Now that process is an example of a question. It is not the exact question on your assignment, obviously, but it will help you out in terms of the process involved. Good luck.